right, happy Tuesday, LinkedIn Live. This is like LinkedIn Live number 5 or 6. And today I'm talking to Mark McKelvey. I'm super excited for this one because we are talking about machine learning and specifically to retail and e-commerce. So Mark and I have worked together for a really long time, known each other for, really long time. And so, but Mark does lots of really exciting stuff, kind of like across all businesses, but he does a lot of machine learning work and a lot of e-commerce stuff, which that relates really well to the retail world and, the kind of stuff that I focus on. So Mark, thanks for joining us. How about we start with just give us a little background on what you do and your company, and that's that story. And then we'll jump into machine learning.
Sure. Well, thanks for having me. I think this is fun.
Yeah.
Our company is Stacked Analytics, and we are I guess you could say full stack analytics company, from data acquisition and collection all the way through machine learning and applying those in systems that are either helping automate decisions or providing you reporting, analytics, things like that. We have 7 partners and then a number of people that help us out as well.
Okay, cool. Awesome. So let's just jump in. So the reason I even thought of this topic is the term machine learning is thrown all over the place. And a lot of times it's used synonymously with AI, and it's thrown all over the place. And a lot of times people don't really understand what it is and what it actually means, and where it's used and where it's not, and what's real ML and what's not. So let's start with how do you define machine learning?
Yeah, it's kind of a strange term, machine learning, and it sounds kind of scary. The machines are learning kind of thing. But
we'll talk about that.
That's more the AI realm. But machine learning are just a set of algorithms, or a set of what's another word for algorithms? Computer models, programs that look for patterns in data. So we used to have statistics, and those also look for patterns in data. Basically, you're trying to minimize some or maximize some function. So make these points close to these points. So find a pattern that minimizes the difference between these points. Right. And machine learning uses some really neat optimization algorithms to survey a large space of variables. So if you're looking for a pattern between how fast wheat grows and how much rainfall you've had, you could almost just put that in a table and look at it and see for yourself without any kind of algorithm.
Yeah.
But when you include rainfall and soil composition and sunshine and bugs and all these other things, it becomes really difficult for our brains to be able to process that many variables. So we need these tools that can look over a large variable space at a lot of different levels and say, okay, here, this is a peak. When all these variables come together this way, crops grow. And that's what machine learning is. It's just a set of tools that help do that.
Yeah, when I describe it to people, there's a couple key points that I try to throw out. It's one, if you're taking the approach of machine learning, you can use a lot more data and be a lot smarter. The example you just mentioned, for any analyst to go through and do that with a high number of variables or features in the data set, it's really hard. It takes a really long time, and it may not actually be that accurate. Computers are really good at that type of stuff, right? Yeah. It doesn't matter how many variables there are. It's just a function of time at that point, and it's usually seconds. So depending on what you're doing. So that's one thing, especially when we're talking about in my world, retail, where we're working with 10,000 locations and trying to figure out stuff. E-commerce is the same thing. You've got millions of variables that you could look at if you're going to the location level in the e-commerce world. It's a really good application of machine learning. The other thing that I typically tell someone who is kind of new to this is it literally is what it says, right? It is a machine learning on the data.
Yeah.
Right? So instead instead of the old way where an analyst has to physically create the model and the math and everything to predict something. In many cases, the machine is learning against that data and it builds a model for you, and then you can go use and predict against that model and all kinds of fun stuff. So
I do that a lot, where I'll take the output of a machine learning trained model, and then I'll go analyze the data. It can condense the space that I need to review, so that I can understand it, throw out all the variables that aren't really making a difference. And then I can look and say, okay, what's actually going on here?
Absolutely. Absolutely. Especially as like we continue to get access to more data and there's more like stuff, like different questions people are asking. It's growing and growing and growing. And then it gets confusing because now there's all kinds of different flavors of it. So let's talk about so we're going to talk about application here in a second, but first let's try to talk about how it's actually done in somewhat layman terms. Like in the work that you do, what are the, how are you physically doing it? What are the tools you're using? Are you using any of the automated ML platforms that are out there? Is it mostly all custom stuff? Just give me a little bit of background on that.
Sure. Personally, I don't use AutoML very often. I'm also typically working with tabular data, so data in a table versus images or video recordings or something like that. Right. So that kind of lends itself to working with decision tree based algorithms to understand the data. And there's also Bayesian algorithms to understand the data. Those aren't layman's terms, sorry. But I'm not using neural nets, which gets a lot of press, like the Chat GPT that everyone's talking about right now. That's a neural net, and it's language processing.
Right.
So the first thing I do is I have to get the data organized into a table. So that is, rows of data that explain, when these conditions were true, this was the output variable. You have some output variable on the right that you're trying to understand. How do these variables drive that? And so get the data cleaned up into a table, and then, I should back up. First, we have to understand the problem.
Yeah, totally.
Yeah. And then you have to take a lot of guesses, like what variables might matter here.
Yeah.
That's a lot of conversations with the business. A lot of times people have very good intuition about what's driving things. And my experience tells me about the types of variables that typically have an impact too. So then you have to go get all that data, put it together in a table, and then you start trying different machine learning algorithms. The keep it simple, what is that adage? Holds true machine learning. You want to use the simplest tool that you can, which makes it very easy to interpret the model results.
Right.
So I'll start with a few. If I can make a simple model using kind of standard statistics, then I'll do that.
Yeah.
But if I need to use something like XGBoost, which is kind of, there's a few other ones like that are pretty heavy-handed, but do a great job of predicting things.
Yeah.
Like back to that, how much will wheat grow, kind of thing. That's what I'm trying to predict. Or will this occur or not? Those types of things.
So this is a little bit of a leading question, but if you look at it's hard to say like a typical machine learning project, but if you just take like a one, maybe where you're focused on forecasting and you're looking at a bunch of data points to include and stuff, is most of your time in the data preparation, or is it in the actual act of running models, tweaking models, optimizing models?
Yeah. So feature engineering is where you spend most of your time.
Yeah.
There's the whole data engineering piece that I'm going to leave out of this, but once you have a model, kind of the most impactful way to improve it is to change the way the input data is represented. So what's an example? So you could have 1 or a 0 for what day of the week is this. Mm-hmm. So you could have a column for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And that might might produce a model that gets you 80% of the way there. But then you might, swap it and say, okay, is it a weekday or a weekend? That's something else to try. It's the same data, you're just represented it a different way. And that might really increase the performance of the model because it cuts out some noise that doesn't exist. So a lot of that's the art of machine learning is just the feature engineering part of it. And,
and so if I can just add to that, for feature engineering is the act of selecting data attributes that you think are going to influence whatever prediction you're trying to make, right? So like if we're trying to predict sales and we're looking at rainfall to try and predict sales of a mosquito product or something, there might be like 5 other variables around outside of rainfall: location of the country, time of year, the temperature of the environment, that also could help us get smarter on predicting rainfall. So feature engineering is like, okay, well, which variables do I use, number one? And then how do I actually evaluate those variables? Do I take the absolute number? Do I do something fancy and take like the percentile of that area in relation to everything else? Do I lag those variables? Like, do I look at rainfall from 5 days ago versus today, or 3 days ago versus today? And does that make my model smarter? And this is like something that, unless you're in this world, no one ever talks about. And it is like one of the things that I've seen analysts be really successful with, especially if you have domain knowledge, right? So the reason I only work in retail is because I have really good domain knowledge, and I've done like a ton of projects in there. And I know that like I'm a little bit more efficient because I've done all this work. It's the same thing with you in e-commerce. It doesn't matter who the retailer is. You can take the background from all of that work you've done in the past to make every subsequent project more efficient. And a lot of that is because you know the variables to at least start with, right? You're smarter about it.
Yep. You nailed it.
Cool.
People don't talk about it so much. They talk about these algorithms a lot, but until you start getting into Kaggle competitions or something like that, where you're competing on your machine learning prowess, you don't think about it so much.
Yeah, totally. Okay, so let's talk about, we've talked about like what this is. We've kind of talked a little bit about how to do it. What are some applications? I'll give some on the retail side, but how about we start with like, what are some recent projects you've done or some recent applications of machine learning in the e-commerce space?
Sure. Before we go into that, I want to say sometimes you have to use a model to do your feature engineering.
Yeah.
So
absolutely.
You have these ensembles of models that are kind of working together. I thought of that while you were talking.
Totally. Absolutely.
But yeah, applications that I've used in the e-commerce space recently. One that I think is really cool is how we're changing user behavior. We're changing website behavior on what we know about the user. So the user comes to the site, and a simple example is you might predict, will they complete this form or not? And maybe you need to collect some information from them. And you can use the variables about the type of browser they're on, the type of day it is, or the time of day it is, and those types of things to predict, okay, maybe we should cut off a few questions because they're on a mobile device and we need to narrow down the number of inputs they have to add. So I think that one was pretty cool. We used a model to predict, are they gonna complete this form? And then we changed the form to a number of different options based on what the model says they would complete.
Okay.
Another one is, it's the obvious one, inventory. E-commerce brand needs to be able to predict, what's going to happen in the future so that they can have enough inventory on the shelves, especially when you're looking at, things that have a long manufacture time. Like if you're selling clothing, it might be a year that you have to place your order. So how are we going to predict how many t-shirts we need a year from now? That was a fun one. But there's always the media mix modeling work. Marketers want to understand which channels or campaigns or tactics are driving the most sales. And I kind of like to flip that question and say, who are my, as an e-commerce brand, who are my customers? Let's break those down into groups
Yep.
and then start doing media mix modeling and product research and things like that to determine what are the right kinds of tactics to take for this group of people,
Totally.
or for this group of people in this time of year, and that sort
Right.
of thing. That
It's
is
so different.
learning about your customer, using their behavior on your website and their purchase behavior and their customer service behavior. That makes you a better brand. It helps you improve their experience. It makes them feel cared for. And it's a great way to build brand loyalty and sell more stuff.
Yeah. Yeah. I'll echo the supply chain piece. That one, the supply chain industry in the like CPG space is wide open for someone to come in and like revolutionize how this stuff is getting planned from the point of manufacture, but all the way through the retailer themselves. I can tell you with absolute certainty, there are giant retailers out there that are planning inventory in Excel spreadsheets. It's happening all over the place with retailers that have thousands and thousands of locations. They have so many SKUs and like not enough highly skilled analysts to like really be able to predict, okay, in this situation, we're going to need this amount of inventory because there's so many variables and they just haven't done the work to, probably do it the right way because it'd take a lot of time. And so I do know there's people working on this. I just talked to a guy last week. But yes, the supply chain one is a big one. Go ahead.
Your point there, like that is true across industries. It's just true in the business world. Like there are a lot of things being done in very old-fashioned ways because it's just never been looked at. And you can bring in a machine learning model and solve somebody's job, and then they get to use their brain for more thoughtful things and take it to the next level instead of spend so much time in Excel or whatever the tool might be.
Totally. And I think I would say that I know from discussions that I've had, you tell me if you've seen this too, but there is like an assumption out there that doing anything with machine learning is going to cost $1 million or at least hundreds and hundreds of thousands. And in my experience, that's not the case. Now, yes, there are projects where that is the case, but like you can get a lot done for not as much as people think as long as you're working with the right organization, right? If you go hire a big company,
you're going to spend $1 million.
Right.
Yeah. I love helping small and medium-sized companies. I feel like I can make the most impact there. And I'm not slowed down by a lot of the bureaucracy that comes with really large companies.
Right. Totally. Okay. So the only other thing I wanted to add to like, how is this stuff being used? Like I said, supply chain is a huge one. Forecasting is a huge one. Obviously, I'm partial to clustering and segmentation and stuff. And when you're dealing with 10,000 locations, K-means clustering models are really valuable for digging into stuff like that. Sure. But also, like you're even seeing retailers use this stuff for loss prevention. And like, if you've ever been in a Home Depot or a Walmart, and sometimes you'll see that the machine that's driving itself cleaning the floors, a lot of times look around that machine and there are cameras on the sides of it, and it's scanning the shelves to understand products that need to be restocked or downstocked. Like there's a box sitting up above on the shelf that needs to be brought down. You just send a bot through the store that's already cleaning the floors. All it needs is a camera and a model on it to tell you, oh, UPC number 457 is not on the shelf. That's the trigger to the worker to go, okay, restock this, whatever this widget is. So like, there's some really cool stuff happening. The loss prevention thing is it's cool, but it's also kind of big brother. So that actually gets to my next question. Like, are there any problems that you see with ML? What are the problems you see with it? Risks, concerns?
I think that probably the most trouble I have with it is a lack of understanding. So there's no promise going into an engagement where I'm building a model that the data is going to tell me anything.
Right.
And, that's kind of a hard sell, right? Like,
Totally.
I'm going to study this data and I'm going to tell you, I'm going to do the best I can, apply all my experience to it. But you might find that it doesn't have a great story to tell,
Right.
or it doesn't predict with the certainty you need to make it useful. You always learn something through that process. You learn what other data you might need to collect. You learn, what variables are impactful, even if they're not impactful enough. But yeah, it can be disappointing, when you throw machine learning at some problem and you hope to find the answer. And that's kind of the difficulty I have with it. And then the
Can I stop you there before you go to the next one real
Yeah.
quick? We should also say you should be very cautious of any large agency or machine or like company, consultancy, whatever, that comes to you and says, we can build a model that is going to solve this problem 100%. Like your approach is, hey, here's how we're going, like, and this is my approach too. Here's how we're going to approach it. Here's how we think we're going to get into it from a data perspective and where we're going to go. But at the end of the day, I'm not going to tell you something that's not there. Right. And especially, I mean, you and I both have a lot of experience in the marketing world. This happens all the time in the marketing space. Yes, there's always positive ROI because we were able to massage the data. It's accurate. It's still true. We just massaged it so that you had a positive ROI. When I've reanalyzed positive ROI campaigns and my analysis did not produce positive ROI. So you just have to, you have to have a lot of trust in the company you are working with. You have to trust that they're doing it the right way, that they're not in it to tell you what you want to hear. So that's an important one. Sorry, go ahead. I just wanted to.
Yeah. I think along those lines, what I was going to go into is unreasonable expectations, which is similar to what I was saying. But people might say, "Hey, Mark, predict what the next product I should build is." Well, there's no history of you building products for me to say what the next one is.
Right.
I might be able to predict a class that seems to do well at this time of year or something. But if there's no data, then the machine learning isn't going to help you.
Right.
And then the other one, I was back to what you were saying. There's a lot of machine learning tools out there that are purported to be ubiquitous. Like, hey, if you use our tool, it's going to solve your problem. But in my experience, I've found that you almost always have to customize to the business. There's no one model fits industry type thing. There's going to be variables that are very particular to how you do business and what your goals and strategies are as a company, that a one size fit all model probably isn't going to cut the mustard. Is that the right term? Cut the mustard?
Yes. It's like, I think like 6 years ago when IBM's Watson had all this press around it, and in the machine learning communities, it was a joke because it was sold as like this artificial general intelligence for business that you could ask any question and it would solve your question. When in reality, probably what was happening is you had a bunch of IBM engineers behind the scenes, like just building models for whatever question was coming up rather than some master machine that, doesn't exist even today. So yes, that's an important one. You don't just buy something that has no context for what you're trying to accomplish. Anything else before I go to the next question?
Nope.
Okay. Well, this is my favorite question. When do the machines take over?
When do they become sentient? I don't know, man. That Chat GPT, it's pretty darn smart, and it can converse with you pretty well. It seems like it knows what it's doing, but it can't turn itself on and off yet. So I think I think it's just going to happen slowly over time. We're going to give more and more power to these models because we trust them. And as that occurs, I think there's going to be far less fear over it. You're just going to build confidence and use them for what you want to. And it'll just continue to happen over time.
Yeah, I think the key is, and I said this earlier, the artificial. So this is part of like machine learning and AI, right? People say AI all the time. Really what they're just talking about is some machine learning model. Artificial general intelligence doesn't exist yet. There are researchers, there are whistleblowers at Google who actually think they have a model that is aware that it's a model. It can still be turned off and on, but they think
I saw that.
hey, this thing actually knows it's not. They know it knows what it is, and we didn't tell it that. So that is concerning. But I also listen to Elon Musk, who thinks AI is more dangerous than nukes we have today. And I actually am terrified of self-driving lawnmowers because that is just a weapon that gets to decide where it goes. And if it decides to point itself at you, I mean, fortunately, lawnmowers aren't very fast. But one thing I will say, one thing that does scare me when you talk about machine learning, or like if you've studied deep fakes recently, that is a very scary piece of technology. And this is like, if you actually do listen to Elon Musk on AI, his real concern is advanced machine learning and AI technology getting into the hands of the wrong people or being built by the wrong people. If you think about deep fakes, for any of you watching, if you haven't looked this up, go look it up. It's pretty impressive. That can ruin someone's life pretty easily. It's like today, if you compare me talking to a deep fake, there's a difference, but that's today. Like think 3 years from now.
And people that don't know you, they're not going to know that difference.
Right.
And one post like that, it can really screw you up.
It can ruin a company. You get a CEO of a company in a deep fake saying some bad stuff. There's all kinds of bad stuff that can happen. And that's one example of some advanced machine learning technology that a lot of people have access to. There's only going to get more ubiquitous. So yeah, there's a lot of great things, and there's also things that we actually should be concerned about in this machine learning world. Well, thanks, Mark. Anything else you'd say about machine learning? Any tips, tidbits, suggestions?
Not in general. I could take a swing at this guy's question real quick.
Yeah, let's do that.
Pavel asked us a question here. He said, are there any experience with successful projects for front of staff in stores? And I think totally, I haven't worked on any personally, but I can imagine a case where, you might have a question about a tool. I go to the auto parts store because I have an old car, and a lot of times they're younger guys in there. They don't know how the vehicle works. So I can imagine a use where you can type in, here's the problem I'm experiencing with my vehicle, and it will come back with some suggestions. I think that could be very helpful for a front of store person.
Yep, absolutely. And I'll go back to that example I gave of the inventory scanners that are actually already in use today. That is removing someone from having to walk through the entire store and figure out what units aren't on the shelf, because they always double check, right? Yes, the point of sale system is tracking inventory. In theory, we should know how many units are on the shelf, but we don't always know. It's not always that. You've got shrinkage and all kinds of stuff that takes place on the shelf, products getting moved to different spots and everything. So, I mean, that's one that's in place today that I would expect, since Walmart and Home Depot are both doing it, I'm sure others, but they put some investment into it. I'm sure it's producing.
There's also chatbots. I mean,
totally.
Those things are everywhere now, and they're getting better and better, where we're getting, sometimes I've actually gotten the right answer from a chatbot before. Right. It's happened.
Yep. All right, cool. All right, Mark. Well, thanks. Let's do this again. There's tons more we could talk about machine learning, even like in the whole retail world. So let's do this again here in a couple months.
All right. Thanks, Zach.
All right. Talk to you later.
See you.